All right. So, first thing we're going to look at is this cube. If I would take a knife or a saw and hack it off right like that, right in the middle, what shape would you see? A rectangle or a square, because you see a blue square. You cut it off parallel to the base, it's going to be the same shape as the base. So if I cut this parallel to the base, what shape would you see? What shape do you see right now? Triangle. So you'd see a triangle. If I cut this off parallel to the base, what shape would you see? Triangle. If I cut this off parallel to the side, what would you see? A rectangle. Okay? Now, if I would take this one, and clip off the corner diagonally. If I'd clip off the corner diagonally, what would you see? If I'd clip off the corner diagonally, what would you see? A triangle. Okay? So that's called a cross section. When you clip off something, that's a cross section. Now, what we're going to be working on is figuring out how many faces, vertices, and edges there are. So you got to know what each of them are. A face is a side. How many faces does this thing have? How many sides does it have? 6 sides. So this thing right here, the number of faces would be 6. The number of vertices are the corners. 1, 2, 3, 4, 5, 6, 7, 8. How many vertices does it have? 8. And edges are the last thing we count. There's 4 edges around the top. They connect the vertices. 4 edges around the bottom. And then 4 going up and down. How many edges does it have? 12. Okay? Faces, vertices, edges. So, on these, triangular prism. This thing, how many faces does it have? How many sides? 5. 1 at the top, 1 at the bottom, 3 around the sides. So it has 5 faces. How many vertices does it have? How many points? 6. 3 around the top, 3 around the bottom. How many edges does it have? 3 around the top, 3 around the bottom, and 3 that connect them. 9. This thing, how many faces does it have? 6. 1 at the top, 1 at the bottom, 4 around the sides. How many vertices? 8. How many edges? 4 around the top, 4 around the bottom, and 4 that connect them, which is 12. Pentagonal. How many faces does it have? 1 at the top, 1 at the bottom, and how many around the sides? 5, so that's a total of 7. How many vertices? Well, there's 5 around the top, 5 around the bottom, which is 10. How many edges does it have? Well, 5 around the top, 5 around the bottom, and 5 that connect them, which is 15. Hexagonal prism. How many faces? Well, there's 6 around the sides, the top and the bottom, to make 8. How many vertices? 12. How many edges? 18. All right. So, let's see what happens. Add these two up. What do you get? 11. Add these two up. What do you get? 14. Add these two up. What do you get? 17. Add these two up. What do you get? How does these two numbers relate in every case? This equals this plus 2. 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 Correct? So, faces plus vertices equals edges plus 2. That's Euler's formula. You don't say Euler. 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 She knows what movies that's from. Back in the 1980s. What? Ferris Bueller's Day Off. There we go. Classic 1980s flick. Ferris Bueller skips school and does a lot of crazy things, including wrecking a very, very, very expensive car by backing it through a plate glass window. Yeah. And so I just ruined the movie for you. But it's a cool 1980s movie. But this is Euler, not Euler. Okay? Bases plus vertices equals edges plus 2. So when they give you two of them, you just use a formula. Because it would be tough to add up all these just by looking at it, right? But they give you the faces and the edges. Bases plus vertices equals edges plus 2. So 20 plus v equals 30 plus 2. 30 plus 2 is 32. 20 plus v. 20 plus what makes 32? 12. There's 12 vertices. Boom. Easy peasy, lemon squeezy. You don't have to count. 6 plus 8 equals e plus 2. Well, this is 14 equals e plus 2. What's e? What's e? 12. F plus v equals e plus 2. 20 plus 12 equals e plus 2. 32 equals e plus 2. What is e? 30. Okay? So, Euler's formula, really easy. You plug in the numbers, you figure out the other numbers. Now, you're going to have a separate Euler's formula for, it says something different on your homework. So, when you hit that, you'll have to work your way through it. Cross sections. If it's parallel to the base, it's the same shape as the base. If it's parallel to the base, it's the same shape as the base. So what is the cross section of this? What shape is it? Pentagon. If I go perpendicular to the base, straight up and down with this, what shape will it be? It'll be a triangle. If I go parallel to this, what did I just make? A pentagon. If I just cut off a little corner of this, what do I make? Triangle. Okay? So if I cut this off any way I go, what is this going to be? Triangle. Okay? All right, the last thing, wrapping. If we take this and wrap it around in a circle, then this becomes this, and it becomes a, what shape? Cone. If we take, and then let me redraw this. If we take this and wrap it around this line, it becomes this, which is, I don't even know the name of it, but it's a cone on top of a cone. We're not going to have to worry about wrapping it this way. I want you to know, if we wrap this around, what does it become? A cylinder. This would be a cone, and so on. So that's what we're doing today. We're doing cross sections, we're going to do Euler's formula, and we're going to do wrapping. And that's the three things that you'll do on your assignment today. Do assignment 11.1 on Google Classroom, not 10.1. I accidentally assigned the wrong one. So make sure you do 11.1, not 10.1, because you've already done chapter 10 earlier, I think. Or maybe you haven't. I don't know. But do section 11.1. Okay, there you go.